Good afternoon, ladies and gentlemen.
Good afternoon.
We have to do this every time. Let's try again. Good afternoon, ladies and gentlemen.
Good afternoon.
That's much better. Welcome to Scifest Africa 2016, and welcome to the official opening day of Scifest Africa 2016, our 20th anniversary. And really, on this occasion, it's a great privilege for me and an honor to be able to introduce somebody who, started as a colleague and really has become a friend of Scifest Africa and a personal friend. So welcome Jim Adams, Deputy Chief Technologist of NASA, who I'm proud to be introducing to you today. As I've said, Jim has become a great friend of Scifest Africa from when we met him 3 years ago when he was doing outreach in Khayelitsha on behalf of the US Embassy. And we also welcome you today, representatives of the Embassy. Welcome to this afternoon's lecture. So Jim Adams is the Deputy Chief Technologist of NASA, and he was trying to explain it to me last night, but really what that means is that Jim oversees all the technology developed by NASA for their various missions, which I think is a pretty cool job. And so, all the technology that's being developed for NASA to go to Mars, which for me I think is really one of the exciting parts, falls under Jim. He's also in charge of all the chief technologists at the various field centers of NASA. So Jet Propulsion Lab, Goddard, each of those centers has a chief technologist, and Jim is in charge of all of those. Before working as the Deputy Chief Technologist of NASA, he was the Deputy Director of the Planetary Science Division at NASA, and you worked on Mars. You were there the day that the rover landed. Yeah. So, Jim, how many missions actually have you been involved in?
In excess of 30, I've lost count.
Okay, he's lost count, over 30. So I really think this is a man who enjoys his work. You can see it every day when you talk to him about NASA, when you talk to him about the work he does at NASA. And before that, of course, you were at Goddard as well, just outside DC in Maryland, where he was, he had various titles and various jobs at NASA. And so with our 20th anniversary, we started having a conversation about, how do we celebrate 20 years of Scifest? And an interesting thing came up, which was, it's actually also the 40th anniversary of Spinoffs, which is a publication that NASA brings out every year to communicate the different technology spin-offs, or the spin-offs of the technology that NASA has developed. And I said to Jim, what would be really interesting is if you could find the first edition of spin-offs. I would love to see the technology in that edition. And that really started a conversation about the lecture that you're going to see today. So Jim, welcome back to Scifest Africa, welcome back to South Africa, and let's hear all about 40 years of spin-offs. Welcome.
Thank you, thank you. So, yes, I am Jim Adams, at least for today, until somebody tells me different. I started my career working for General Electric Company, designing spacecraft and satellites and sensors. I even helped to design the first space shuttle toilet. Let's see, I have a degree, my undergraduate work is in physics. I have a master's degree in electrical engineering. And after that, I said, I'm done with school, I just want to build satellites. And so that's what I did. Over the years, as Anya pointed out, I've been involved in almost 30 or more than 30 different missions to space. And I've had the privilege of leading several teams to do amazing things, like landing on Mars. And you can see a life-size cutout of the Mars rover out there. Like putting New Horizons together, the New Horizons probe that recently flew by Pluto. Like helping to design the architecture that will make the International Space Station work. And now today, we're heavily involved in trying to figure out the best way to get to Mars. How will we fly human beings to Mars? Of course, we're already at Mars because we've got robots there now. But in the future, we want to send human beings. That's a huge systems engineering problem, and those systems engineering problems will be solved by technology. The technology that we are working on creates ideas among people around the world. They say, oh, we can use this bit of technology to go do something else. And that's what a spinoff is. You know, the NASA budget is a huge amount of money. It's like $19 billion a year. That's a lot of money. But it fuels an economy globally that's $330 billion annually. And that's not just NASA. That includes SANSA, which is the South African National Space Agency. It includes the commercial industry, like the DirecTV guys that broadcast television to you. It includes all of the radio satellites that you listen to. It includes weather satellites, and it includes some of the aeronautics work that we do. So there's lots of ideas that are generated, but what I think is really exciting is that there are people around the world that take those ideas that we might have used to go to space, and they bring them home. They come up with new and innovative uses for them. And that's really what Spinoff is all about. Spinoff is taking NASA's intellectual property and moving it into something that is economically viable here on Earth. And so I've got several stories, little vignettes, topics to show you that we've identified over the years. So far to date, I believe there's a library of 2,000 different spinoffs. You can search that library if you want by going to spinoff.nasa.gov. And there, all of it is there. So let's see. So yes, there have been 40 years of spinoff. It actually turns out there's 39 publications because we skipped a year to make the publication line up with the year at one point. But this is Anya's original request. The very first spin-off was published in 1976 to celebrate the bicentennial, that's 200 years, of the existence of the United States. The very first spin-off, in the very first spin-off book, was about how materials used in NASA rockets made for better tractors and plows, and allowed companies to make plows that could plow longer before breaking. So that's a good thing to bear in mind because we'll come back to that in a minute. So in the 1970s, people looked funny. Here's four things that came from our investment in Apollo. So the Apollo missions were developed in the 1960s, but then these products came out in the 1970s as a result of the investment in Apollo. The Goodyear company worked with NASA to come up with new fibers and new technologies for making rubber work well with tires. So when you ride on a Goodyear tire, you're riding on NASA technology. The Apollo mission had to keep astronauts' hands and feet warm, so they developed a thin film resistive heating device that then the skiing industry picked up and started to put into ski boots and ski gloves. And today, when you see a thin film heater anywhere, you're using NASA technology. This is really cool. This was me when I was in 1975. Actually, I looked better than that. So how many of you know what this thing is? It's vinyl, right? What's on it? Music, right. Today we don't use those very much anymore. But when you put them on a turntable and play them, they needed just the tiniest bit of lubricant. Well, it turns out that the record industry turned to NASA and they used a lubricant that we developed for the Apollo space program to put over top of the vinyl records so that they would play better, last longer, and there would be less wear on the needle stylus. This one's really cool. When the astronauts would return from the from the moon, they would splash down into the ocean. And some of our initial tests, we would splash down the capsule, the astronauts would get out of the capsule, they'd get into life rafts, the helicopters would come over and try and pick them up off the life rafts, and the life rafts would turn upside down. It'd be pretty much a bummer to go and be the first man on the moon and then drown in your own ocean after you got back. So NASA developed a technology for those life rafts that's really from the waist down here. And those life rafts now have baffles underneath them that collect seawater. And so the seawater underneath the life raft here fills up this area and makes it more difficult for the life raft to invert, to turn upside down. And in that way, then, we could hover a helicopter over that region, create some turbulence, but still get the astronauts out of the life raft. Today, nearly every life raft that's on a cruise ship or a sailboat uses this sort of technology. In the 1980s, we were busy designing the space shuttle. And we had technology left over from Apollo as well. Oops, we'll talk about the 80s first. So here you see a worker in a flame retardant suit. NASA developed a material called astroquartz. Astroquartz is a sort of an impregnated Teflon that is extremely resistant to heat. And then when you marry that with a reflective coating, you can actually keep a worker safe if he has to walk through flames. Usually emergency workers use this sort of thing. NASA developed advanced sensors. Usually we're trying to make sensors as light as possible so that we can fly them deep into space, because the more weight you have to fly, the more expensive it is, the less other stuff you can fly. So we had developed a piezoelectric sensor. It's a sensor that when you press on it, it puts out a voltage that's relative to the pressure that you put on it. So you could tell whether or not something had hit you hard or had hit you soft. We were using it to detect dust impacts. But there was a fella who was into the martial arts, Taekwondo and karate, and he thought, well, gee, maybe I could take a license for that piezoelectric sensor in a thin film and use it to measure the impact of my trainees. And he formed a whole business around supplying these sensors for the martial arts because we were trying to detect dust impacts in space. Black & Decker, I don't know how many of you know what this is. Anybody know what this is?
Dustbuster.
That's a Dustbuster. So no, NASA didn't invent the Dustbuster, and we didn't take a Dustbuster to space. But what we did do was we worked with Black & Decker company to develop an algorithm to know how best to charge the batteries. And today, the method of charging batteries on Black & Decker products, including handheld electric drills, leaf blowers, and I even have an electric chainsaw, right? They are all driven from that original work of investigating the best way to charge and recharge batteries. This one's interesting. It makes you think that maybe we invented the floppy disk. Most people don't even recognize that as a floppy disk, and some people don't even know what a floppy disk is anymore. But in fact, when we were putting the tiles on the space shuttle, there are many, many of them, and they're all unique. And we had to keep track of them. They were reusable, but oftentimes we'd take them off to work on the space shuttle and then put them back on. So we developed a relational database system. It was the very first relational database in order to keep track of space shuttle tiles. Today, just about anything that you track in a database is as a result of that early work in relational databases that NASA invested in. Predominantly because we wanted to keep track of the tiles on the space shuttle. In the 90s, the Lear company was developing private jets. And NASA's Langley Research Center had been doing advanced work in the area of wing design. And these these kinds of blended wings between the body and the front of the wing, the leading edge, was work that NASA was leading the community in. So they came to us, and we worked with the Lear company to design highly efficient jets so that corporate entities could buy their own jets. The Ames Research Center and the Jet Propulsion Lab worked with a number of different companies in the 1990s to develop handheld email devices. Now that may not seem like a big deal to you, but if you grew up when I did, we didn't even have cell phones. In fact, the region that my wife grew up in, everybody shared a phone up and down her street, right? One phone for 15 families, right? So the idea that you could connect a device, a handheld device, into a telephone and get messages was groundbreaking in the early 90s. And it was NASA algorithms and technology, miniaturization technology, that enabled us to do that. In the sports industry, our investment in materials and understanding how materials respond to environmental changes like impacts and heat enabled this particular golf club company to make better golf clubs that would drive golf balls even further. Also, NASA is always interested in trying to understand the temperature of things. Why? The temperature of things tell you about the energy state of it, right? So we've developed over the years hundreds of temperature sensors. In this particular case, this company called BD picked up our temperature sensor and turned it into a handheld thermometer, so you didn't have to stick a thermometer in your mouth or anywhere else. So in the 2000s, NASA worked with a variety of emergency response companies to develop a robotic technology that enables robots to get into buildings that might be unsafe for human beings in order to look for things like perhaps bombs, or to look for unconscious victims, or maybe to do some work that would be too dangerous for a human being. So a collaboration between NASA and US industry has yielded this robot, which I forget the name of at the moment, but it's in hundreds of fire departments across the United States today. So, how many of you were at Scifest last year? Yeah. I brought with me a friend. Her name was Katie Coleman. Do you remember, did anybody of you go to Katie Coleman's lecture? She spent 6 months on board the International Space Station. She's an astronaut. And one of the things that she tells me is that because of the rigors of space, because floating around in microgravity causes your muscles to atrophy, because you're not exercising as much as you should, your bones start to release calcium, and it makes it much more difficult for you when you land on Earth. We force the astronauts to exercise 2 hours a day, right, in space, just so that their muscles don't die down and they don't lose too much calcium in their bones. Well, the technology that we've developed in order to enable astronauts to work on treadmills and lift weights in space is technology that has been taken and directly applied here on Earth. And this is a system that is now in hundreds of rehabilitation centers that can be programmed to either lighten the load as a person is maybe learning to walk after back surgery, perhaps, or it can make the load heavier if a person is trying to develop muscle mass. And these are all over the United States. One of the things that we've done is advancements in materials. In the 2000s, we were able to take our understanding of how airflow flows over certain kinds of materials at microscopic levels and enable a textile company to make speed skating suits that enabled US speed skaters to place well in the Olympics. I've always wondered about this picture. It looks like his blade is coming off. Are speed skater blades hinged? or is he just destined to crash? Also, in the 2000s, some gentlemen at JPL were working on welding parts together. Space technology required us to, in a very precise way, using lasers, weld these two parts together. Well, that was creating ultraviolet light. And they were looking for a new way of shielding those individuals from the exposure of the ultraviolet light that they were creating because of the welding. Well, as it turns out, birds of prey do this in their eyes automatically. There are little droplets of oil in birds of prey that help the eagles and the falcons not only be shielded from UV light, but once they're not exposed to UV light, then they can actually see what they're hunting better. And so that technology, we patented this technology to put it into a curtain so that a welder could actually see better of what he's welding. An eyeglasses company came along and formed this product called Eagle Eye and picked up our technology, our patent, got a license for it, and turned it into sunglasses. And now I can walk around sports venues and airports all across the United States and spot the NASA technology either on the eyes or on the heads of people across the United States. This one, I love this one. There's actually 3 spinoffs in this image. Can you spot them? Let's see. Who's got one? I'm looking for kids. The grown-ups are seeing it.
Winglet?
Yeah. You're not a kid.
I can that.
Yes. So this bent wingtip doesn't mean that the pilot took a corner too fast and ran into the side of the terminal. It actually changes the airflow off the tip of the wing so that the vortices coming off the tip of the wing provide extra lift for the plane. And when you do that, the airplane industry in the United States, the airline industry, can save billions of dollars a year in fuel costs. That technology was developed at NASA Langley Research Center. The next thing is we've been working with the Federal Aviation Administration to try and find ways to reduce the sound of airplanes. You know, in the 1960s and 70s, we'd build our airports way away from cities. But now by 2010, the cities had grown out to the airports. And the people that are living next to the airports, they're complaining about the sound of the airplanes landing and taking off. So it turns out that if you can create a bypass around the jet engine and then blend that cool air with the hot air, then you can reduce the sound that people hear on the ground. And that's what these shark's teeth or chevrons actually do. And then the last bit of technology you can't actually see. NASA's interest in maintaining safety at all costs developed a methodology for creating checklists and assuring that the checklists are followed. They have been adopted by U.S. airlines and airlines around the world to make sure that when we fly, we're flying safe. So in the 2000s, we were looking for better ways to feed astronauts. And no, we don't feed astronauts with baby bottles. What we did, we started looking at nutrients. And we were able to isolate a nutrient called DHA, which today we happen to know is in fish oil. And most health food nuts will tell you that fish oil is good for you. So we learned that in the 2000s. We patented this method of obtaining DHA from algae. And we were able then to develop foods that were low in mass, but also kept our astronauts as healthy as possible in space. A small company in Pennsylvania picked up this technology and decided that they could provide dietary supplements for for a variety of things, but they started with baby formula. So baby formula contains a supplement with DHA in it to assure that the infant will grow healthy and strong, and it's using NASA technology to do that. Today, that business is worth about $5 billion annually. One of the interesting things is NASA's interest in aeronautics and efficient air flight was transferred to the trucking industry. There was a guy who was riding to work on his bicycle one day, and he worked in the wind tunnels measuring the turbulence around wings at NASA Langley's Research Center. And he would be passed by these trucks and get nearly knocked over. And he said, gee, I wonder if the technology we're working on to transform the turbulence, like the bent winglets, of the airplanes and reutilize that turbulence can be used to make bicyclers more safe on the roads. And that became the aerodynamic fronts of trucks. When you see those fairings up top here and the way the cowling is made on a truck, and then sometimes you'll see little tabs down the bodies of the trucks, those were all NASA technologies that were a result of our investment in aerospace. The interesting thing is NASA said, we went to the trucking companies because we were having an energy crisis at the time, and we said, hey, would you like this? Why don't you guys start doing this to your trucks? And we actually outfitted a truck, and we said, see, it's much more fuel efficient. But back in those days, the way that they overcame, the way they got better loads and speed was they just put bigger engines in it. So the trucking companies all said, no, we don't really need that. We know what we're doing. And then the next year, every trucking company, when they released their new truck, it looked like that. So even though they didn't license our technology, they took our idea and improved upon it and made something that saves fuel, enables more goods to market, and makes people safer on the roads. So, what's the spin-off in this picture? Cell phone. No, NASA didn't invent the cell phone. So, the camera, exactly right. So, a fella named Fossum at JPL in the 1970s was working on how to make highly accurate scientific sensors, imaging sensors, to take pictures in deep space. As I've said before, you want to make them as light as possible, as small as possible, but you want the best possible quality that you can get out of it. So he took the CCD, charge coupled device design, and improved upon it and made something called active pixel CCD. And so today, nearly every iPhone that's released has a NASA-developed charge-coupled device, active pixel charge-coupled device camera in it. And it's the active pixel part is the thing that enables the camera to find your face in the field of view before you've even taken the picture, or to change the focus automatically as you're getting ready to take a picture. That's all NASA technology. So remember I said the very first spin-off was about plows pulling, tractors pulling plows more efficiently and with less breakdown. Well, the very last spin-off that we've been working on, it's not even been written up quite yet, is that John Deere has picked up a patent from us. Well, what is that? John Deere is a big tractor company in the United States. In the 2010s or so, the Federal Aviation Administration came to NASA and they said, you know, we've got lots and lots of airplanes that are using GPS to guide themselves, but we do not allow them to land using GPS signals. Well, why? Because the signal from a GPS can be degraded such that you would only know your position to within 10 meters. Well, being off by 10 meters, if you're trying to land on a runway and you're actually over here when you think you're over here, you could actually be landing either on the wrong runway or you could be landing in the grass, right? Very, very dangerous. So landing with GPS, they weren't allowing that. So NASA worked with the Federal Aviation Administration and came up with an error-correcting GPS that allowed us to know our position to within 1 foot. And now suddenly the airlines can trust their GPS signals all the way down to the ground. Much safer, much more accurate than ever before. So John Deere saw that and they said, hey, you know, we're using GPS signals in our tractors to guide them as they plow the fields so that they get the most efficient plow on the field. And they said, sometimes we replow a row because of the error. So they took that signal, that error correcting GPS, they've put it into their tractors that are pulling plows, and now farmers are getting much more acreage out of their plow than they ever did before because there's less error associated with the way they're plowing. The other interesting thing is that John Deere took it a step further and they said, well, gee, if we know where we're at so accurately, maybe we don't need a driver. And today in North America, 75% of tractors are autonomous because of the accuracy of the GPS signals coming out of the GPS receiver in John Deere tractors. So, if you fly on an airplane, you sail on a boat, or perhaps you go backpacking, you ought to be taking an emergency locator beacon with you. If you're flying on an airplane, there's one called a black box. NASA worked with a number of government agencies, both inside the United States and out, to develop a standardized method of emergency location. So when this beacon goes off, like somebody's boat overturns in the ocean, the beacon goes off, a signal goes up to a satellite. Generally, it's a weather satellite from the National Atmospheric and Oceans Administration, NOAA. And then it's relayed back down to a ground station at NASA Goddard Space Flight Center. And then from there, communications, we're able to geolocate the position of the person that's having the problem. We can send a communication to the Coast Guard, the Park Service, emergency rescue people, or health officials, so they'll know how to go save a life. To date, actually as of 2010, 35,000 people had their lives saved because of this. It's kind of an ugly device, though. When you ride on an escalator, especially in the United States, there's a NASA algorithm that controls the way the motor responds to the load on the escalator. When there's nobody on an escalator, the motors are not working so very hard. When there's lots of people on the escalator, they have to work very hard. Well, so that means that you design the motor for the maximum load. Well, if there's nobody on it, you're wasting energy if the motors are drawing full current. So we've developed a variable motor controller that adjusts based upon the load on the motor. And today, every escalator and almost all elevators, and even some air conditioners and washers and dryers in the United States use this algorithm or this, it shows up as an algorithm or a small circuit to change the variability of the load on, change the current going into the motor because of the variability of the load. And so the United States is saving energy as a result of this. And I believe that that has now come overseas and it's being used worldwide. So I don't recognize this place. Actually, when I was given the notes for this slide, somebody told, or the notes actually said, this is a soccer stadium in Durban. And I looked at it and I said, that can't be right. And so I actually confirmed, I might have even written to Anya and said, this is Cape Town. And so what is the spinoff in this picture? The roof. Yeah, the roof. So in the 1960s, NASA was looking for ways to protect astronauts from the rigors of space, especially the sun, the heat from the sun, and the micrometeoroid environment. So when an astronaut would do a spacewalk, he'd get into a spacesuit. It looks pretty much all white. The same, by the way, color as the roof of this stadium. The fabric that we developed is an impregnated Teflon. And it was patented by a company in upstate New York, the state of New York, who then said, well, gee, we can make spacesuits out of this, but we could also make it in large bolts, and it's extremely strong, and it stands up to weather extremely well. And today, many stadium roofs are made out of a fabric that was developed because we needed to keep astronauts alive in space. Also, if you ever fly into Denver International Airport in Colorado, it's got like these tent-like structures, and that's all the same material as well. So memory foam. Just about everything you sit on today has memory foam. That was a technology that was developed by NASA in the 70s, and I realize I'm going backwards in time, but it was developed in the 70s by some guys that were looking to figure out ways to improve survival on airplanes in the event of an accident. They were looking for ways of absorbing energy, and one of the best ways to do that is to crush something. But if you crush it and it doesn't bounce back, it's not usable another time. And so the idea of memory foam came up at NASA Ames Research Center when they were doing that research. They patented it. Today it's not only in mattresses, it's in football helmets, it's even in horse saddles to keep people more comfortable. I love this story. When we were launching the Apollo rockets, you can go back and watch the video. The rocket would take off, and you would see these umbilicals fall away. And in order to assure that the umbilicals got out of the way of the rocket, there was a swing arm that would swing out of the way. Well, when it got to the end of travel, it was bouncing back. Well, it would be a real bummer to have the rocket take off and then the swing arm to bounce back and then hit the bottom of the rocket on its way up. So we developed a fluidic damper system and patented it so that the swing arm would bounce back and stay back, or would swing away and then stay back. Some really smart people picked that up and said, hey, we can use that to dampen vibration in a variety of things. In the United States, it's used to dampen vibration in buildings, especially in California, in earthquake-prone zones. In London, they built this bridge called the Millennial Bridge. And when they opened it, it shook so much that people were afraid to cross it. And they shut it down because they thought it was unsafe. The City of London went to the company that had the patent on our fluidic damper system and said, can you help us with this? And some guys came out with their little measuring devices and accelerometers, and they went back and they did some pretty heavy-duty maths, I think. And they came up with a system of several hundred of small fluidic dampers that they've mounted on the Millennial Bridge. You know, the bridge had become a joke. In fact, in London, they refer to it as the wobbly bridge, right? But when you put these dampers in the right positions on the bridge, it settles right down. And not only can you walk on it, you can also drive on it, right? So now the Millennial Bridge is open, but they still call it the wobbly bridge. So, heart transplants. South Africa has a rich history in heart transplants. But while somebody is waiting for a heart, while a patient candidate is waiting for that precious, life-giving heart to show up, he needs to be kept alive, or she needs to be kept alive. One of the things that's really important is the efficient pumping of blood around the body. One of the things that's important in a space shuttle engine is pumping fuel into the engine efficiently. So this device actually uses technology from the space shuttle main engines to pump blood through the entry and the exit so that people, it's a heart assist device basically, it keeps people alive while they're waiting for a transplant. In fact, it's so efficient it can run on batteries for 8 hours. So the person doesn't actually have to be plugged into the wall or stay in a hospital. They can go about their daily lives while they're waiting. And it's so small, it's only 3 inches long, that it can actually be used in pediatric patients. So to date, 1,500 people have had their lives saved because of taking this implant. And 500 of them, I think it was 451 of them, have been children. This one's especially important to me. A particular developer of a pacemaker was having problems because the insulation on his wires that go from the pacemaker to the spot on the heart was breaking down. Well, that's a problem, because if the electrical signal, you see the electrical signal is supposed to come down this way, right, and stop here and stimulate this region of the heart at the right time. But if it gets out here and stimulates this region of the heart at the wrong time, you could think you're having a heart attack. The reason that's important to me is my mother has one of these. So the fact that the insulation on the wire was breaking down was a problem, and he came to NASA and he said, "What do you got?" And we said, "Well, we've got this polymer that if you coat in your wires in, will probably not break down." And so today, thousands of people are using heart pacemakers that have NASA technology in the coatings on the wires in their bodies. If you want to know more about the innovative ways that people have taken NASA technology and turned it into something to benefit mankind right here on Earth, you can go to spinoff.nasa.gov, where every one of the spinoffs is held or is housed. What I would encourage you, if you're younger in this audience, to do is to continue to be creative, to think out of the box, to try and find ways to take an idea that somebody developed over here and use it over here. Then you'll have your own spin-off. And as NASA goes to Mars, we will generate thousands of new technologies, thousands of new patents, and thousands of people will have the opportunity to be creative with those technologies and perhaps change life on Earth. Thank you for listening. Do we have time for questions? How much time do we have? 15 minutes. Okay, so I told you I've had a long career, right? And one of the things I'm pretty bold about is I can answer almost any question. Every now and then I get stumped, but I told you I've worked on everything from toilets in space to probes to Pluto, right? So if you've got a question, I'm interested in answering. We can do questions for about 10, 15 minutes. Wendy.
How did you actually stabilize the bridge and make it the wobbly bridge in London? How did you actually do that?
So I didn't do it. A company who took our technology did it. And I believe that what they did was they mounted these fluidic dampers on the underside of the bridge at the right spot so that it dampened the harmonics it was seeing from natural vibration. Yeah.
Jim, sorry, if we could just ask questions to go into
Oh, yes. Is my mic not working?
No.
Oh, I see. Yeah. And by the way, I give out stickers to learners that ask good questions. That goes to Wendy.
I'm interested in the interface between NASA and the private sector. Mm-hmm. You said several times we developed this technology and then this other company picked it up.
Yes.
How does that work in practice?
Yeah, that's a really good question. And you get a sticker too. Right? So we have this office that works for me called Technology Transfer Office. And so we've have access to all of NASA's intellectual property, which is patents and software, in a catalog, in a system that people can log online if they want and see what we've got, right? But the purpose of the Technology Transfer Office is to make it easy for an entrepreneur to find a technology that maybe NASA has developed that could make his job more efficient or run better or solve a particular problem that he's got. But I will tell you that most people don't even know to go to look on the internet for NASA's Technology Transfer Office database of available technologies. What really happens is there's word of mouth. And so we put out several publications a year, one of which I'm talking about today, Spinoff, that encourages people to think about ways that they can engage NASA for technology. The other is something called Tech Briefs, which is also online, which is, those are ideas that are available for patent that maybe we haven't thought of innovative ideas with. And then just meeting with the public. We have NASA 10 field centers around the nation, and they hold seminars, sometimes virtual, sometimes in person, about solving problems with NASA technology. And they attract tens of thousands of entrepreneurs a year looking for solutions to particular problems. So that's the way we do it. Once an entrepreneur says, I'm interested, then it's a matter of the legal guys getting together and creating a license to our patent. We do. We actually charge a fee for our patents, but we don't charge an exorbitant fee. And in fact, at times, we're criticized by some of the press by saying, they say, well, the fee that you charge for your patent doesn't even cover the licensing fee with the Patent Bureau, let alone the cost of developing the technology. Well, that's not the purpose. The purpose of the fee is to assure that the entrepreneur is serious, right? Because if they take a license on our patent, then that means that somebody else might not, right? And so we do charge a fee, and a significant portion of the fee goes back to the employee who invented the device in the first place. Yeah.
Okay, can we choose three and then hands up if you want questions? Okay, I'm going to start with learner in the middle, and then gentleman in the white t-shirt, and in the front here.
So I'm not sure who the learner in the middle is.
There we go.
Okay, hello. I wanted to ask, is Area 51 real? Because we always hear of there being a secret sector where, you know, experiments are carried out and stuff like that. So, in all your years, have you found, is there maybe a possibility of it being there?
So there is an Area 51. I've never been there. And the answer is that it's used for military storage. There's no truth to the idea that we're keeping secret alien life forms there or anything like that. The bottom line is that NASA as an agency, we don't keep secrets. Our ideas are things that we want to share with people. And so the very thought that NASA could keep something like that secret is nearly impossible. So, but that's a good question. Why don't you hand the sticker back to him?
Oh, if we can pass the mic down to the end of the road.
I also joke around from time to time and I say, well, you've heard of Area 51, but have you heard of Area 52? That is a joke, by the way. Don't go with that.
That's what he says.
I'm just curious, how does NASA communicate with the astronauts when they are in space? How do the signals get sent? And secondly, how delayed is it?
Ah, good question. So hand this back to him, will you please? Thank you. So we use radio waves, just like radio here on Earth, but we focus them using dish antennas, kind of like you use dish antennas to receive TV signals. The wavelengths are different because they're assigned by an international telecommunications union that's, I believe, attached to the UN. So there's certain wavelengths or bands that are specific for deep space communication. And so we use those bands. The most common is S-band, but most efficient is Ka band. And the problem with Ka band is sometimes If there's too much water vapor in the atmosphere, it gets attenuated. So we use pretty much standard radio communications like you would with an airplane even to communicate with astronauts in space. The question of time delay is really about distance because there's a time delay anytime you communicate with somebody with radio waves. It's just that if you're really close to them, you don't notice it, right? The time that it takes a radio wave to get from me to you is the speed of light. And so the speed of light takes the same amount of time, it goes the same speed whether you're trying to talk between the Earth and the Moon or the Earth and Mars. It's just that the distance is longer. So Mars is so far out that it takes sometimes as much as 21 minutes for a radio signal to get from Earth to Mars or from Mars to Earth. The radio signals from Pluto, from the probe that we flew to Pluto, 4 hours. I always think that's kind of interesting that those radio signals would be in space. They're like little, it's just like light. It's photons like we measure with telescopes, right? They could be in space. So the New Horizons probe at Pluto could broadcast a signal and then suddenly, let's play pretend, disappear, right? And these little radio waves would be in space for 4 hours before anybody on Earth hears them. And we would have no idea that the New Horizons probe had disappeared. The same is true when we're looking at distant galaxies. We're looking back in time because those light waves were emitted at light years earlier. And now they're coming and those photons are falling on the receivers, which in that case would be telescopes. So it all has to do with the speed of light and distance. It's a good question. We got time for one more? Mike.
Jim, one occasionally hears misinformation of inventions attributed to spin-offs from space which weren't.
Yes.
Some that come to mind, I may or may not be correct, are barcode, cordless drills, for instance, Teflon-coated pans. Can you give some examples?
So no, Teflon was not invented by NASA, but we picked it up really fast because it's really useful, right? One that people use a lot, think a lot, is this powdered drink called Tang. Was very popular in the 60s. NASA used it in space to hydrate our astronauts, but we did not invent Tang, right? So those are two of the really cool ones. Barcodes, no, that wasn't a NASA technology. In fact, we used it for a while, but we're moving on to things like RFID tags and that sort of thing. So. Cordless. Oh yeah, that was the Dustbuster earlier. That was developed in collaboration between NASA and Black & Decker. Yeah.
All right.
So, do you want a sticker, Mike? So.
I'm going to take two more, the one in the middle and Ernie, just because we don't.
Yeah.
Yes, my question is mostly on fuel efficiency. The amount of fuel that the rockets are using and the amount of smoke coming out, are you looking at a more efficient way of getting payload into space without burning so much fuel?
Yes.
That's the first question. The second question is the rockets that have been sent to space. I've heard that from SpaceX they're planning to make them reusable once again. And how is that going to work out?
Yeah, all right. Those are two really good questions. Let's hand him a sticker too. So so we are always looking for more efficient rockets, constantly, because the most drastic thing about a space mission is the launch, right? The biggest expense sometimes is the launch, right? 90% of the fuel that we spend on a space mission is simply to get it off the Earth and into low Earth orbit, right? So we're constantly looking for new ways, more efficient ways to launch. One of the solutions may be to not launch it at all, but actually to build it in space. And we've actually started 3D printing in space, and we can now 3D print not only plastics, but metals and insulators. And at some point, we'll start mounting chips to those things, and we'll have circuit boards and structures that don't even need to go through the rigors of launch at all. We'll just 3D print a spacecraft and then attach a more efficient rocket system to move it on further out beyond Earth. So that's an excellent question. Remind me about the second one?
Reusable rockets.
Oh, reusable rockets. So wasn't that cool? Anybody see SpaceX land their first stage back at the pad? It took off, it deployed a bunch of satellites, and then it returned and landed upright on a launch pad. That's way cool and extremely efficient if they can begin to reuse it. Now, it's not easy. And so that one time was a success, but they've had a string of other times where they've tried and it hasn't worked so well. But every time they try, they learn just a little bit more.
Yeah.
And I think if they keep trying, if they're persistent, they will make it happen. I think that's an awesome way of improving the overall efficiency of a commercial system like the SpaceX Falcon 9. That's a great question. Did you have one more?
Question was it, yeah?
Yeah.
Sorry, I should maybe come to your next lecture and give it to Don. But I was just wondering, it's all very well getting to Mars. Have you got a way of coming back?
Not yet. You want to go? So, actually, one of the meetings that I was at before I came to South Africa was the debate over where are we going to get the fuel for the Mars ascent vehicle. That's the thing that the astronauts have to get into in order to get back off of Mars. You know, like you said, it's all very well and good to land something there, which we've demonstrated we can do pretty efficiently, right? But getting off the surface, the only time we've ever taken off the surface of another solar system body was Apollo. And that was way easier. There were only 2 astronauts. The moon is much smaller, so it's less gravity than Mars, and there's no atmosphere. Huge, huge challenge to develop the Mars ascent vehicle. And one of the standard engineer's ideas is take all the fuel you need, land it on Mars, and then use it to take off. Well, that you pay an enormous price per kilogram of that fuel, because you think about the expense that you have to go through just to land that kilogram of fuel on Mars, just to get it to Mars in the first place, just to get it off the surface of the Earth in the first place, right? We call that wheel ratio. And it has a wheel ratio of something like, for every kilogram of fuel in the Mars ascent vehicle, it's like a factor of 16 kilograms of fuel we have to start with on Earth. We want to cut that down, way down. And so we might look at using the water and the CO2 on Mars and create a little chemistry lab to electrolyze the water and recombine it with the carbon and the carbon dioxide that we find on Mars and make oxygen and methane maybe? Or maybe we'll use oxygen and hydrogen as the fuels for the Mars ascent vehicle. But no, we have not figured it out quite yet.
All right, I'm afraid I am going to stop it there. I know there's a question, maybe chat to Jim later.
Yep.
Jim, thank you very, very much for your time. We appreciate you coming back.
Thank you very much.